I'm with SEQ Catchments, but many of you would know that we've just gone through a wonderful marriage with Healthy Waterways, so that logo won't be around for much longer. This project that we're doing with shellfish restoration in the Pumice Stone, that's funded through the Healthy Country program through the state government, but we're collaborating also with James Cook University, and I've put this slide together with Ian McLeod. Some of you may know Ian from the Tropwater team, and working with the Nature Conservancy with this project. The shellfish occur in intertidal and subtidal reefs, and these really haven't been considered for water quality improvement over the decades. It's really only been the last 2 decades that attention has been turned towards the opportunities that they might offer for water quality improvement. And probably this is largely because disease has been the greatest driver of research into shellfish work, and it's been looking more at source inputs from large-scale agriculture and other catchment inputs. So it's a fairly new research area to be looking at the water quality, and I won't be delivering too much data today because, frankly, it's not around. But I'm sure a lot of you are very aware of the huge cultural importance that shellfish had for Indigenous people across the temperate world, and the midden heaps are testament to that. Manhattan, for example, you may not know, that was built on huge midden heaps, and all of Pumice Stone, Moreton Bay was very, very rich with oysters. A lot of them these midden heaps were dredged for lime and used for road base, so there's not many of them left, but it's a very important part of the culture, and it must have been very dense, the aggregations in the past. They were dredged in Pumice Stone, for example, between 1880s and to 1930. In those 50 years, most of the shellfish have gone. They were taking out 300 bags a week. So across Australia and across the world, there's an enormous amount of work going on with shellfish restoration work. TNC, the Nature Conservancy, is spearheading it a lot in America, and certainly here. We've got a national shellfish restoration network happening, and there's about 6 projects around Australia. It's really young and lots of learnings coming from overseas, but as I say, we've had very little work to build the metrics in our Australian situation. In Pumice Stone, the range of partners that we have, all levels of government, the local fishing group, there's so many coastal stakeholders because there are so many benefits of having the shellfish, so they're really broad buy-in from a lot of, grateful for the Moreton Bay Regional Council to be kicking in some initial money for the start of that. Looking at the ecosystem services that shellfish reefs can offer, they fall broadly into 2 categories: biological processes and the physical structures. Of those, 6 services, goods and services fall out. I've included cultural values there because really they're extremely important to add. But the 2 that we'll be talking about today, with water clarity and nitrogen removal, to do with the biological processes. There you go. Oysters can filter 50 gallons per day of water, which is the equivalent of 36 Olympic swimming pools. That's a hell of a lot passes through those bivalves. A good description of it with New Zealand green-lipped mussel. Bit of turbid water, put a green-lipped mussel in, and in 15 minutes it's clear. So it's a gorgeous indication of just how that can do. The green lip is particularly good at that. How that works, the small particles of the plankton and other suspended non-living matter greater than 3 micrometers are ingested. The remaining particles are bound in, and there's mucus pellets that we call pseudofeces, and they drop to the bottom, to the seafloor, build up, are sunk into it. The whole, in clearing the water, it also fertilises the seabed and improves the vegetation, marine vegetation, which in turn improves the oxygen, dissolved oxygen levels. With nitrogen removal, it's a bit more of a complex process with the nitrogen cycling. So the feces from the ingestion of plankton and other detritus that falls to the seafloor, as well as the pseudofeces that from the mucus pellets falling to the seafloor, they build up the microbial activity on the seafloor, which helps with the denitrification. So it's a whole process that actually improves the denitrification that goes on in the anaerobic seafloor as it sinks into it. The organic nitrogen is increased and in turn changes the microbial community further. In diagrammatic form you can see the ingestion there. Some of the nitrogen goes into forming the shell of the oyster, and then some into the pseudofeces, some into the feces, and goes down into those biodeposits and becomes, in the anaerobic layer, can be denitrified. So this denitrification process, as I say, hasn't been quantified in Australian waters, and that's an active area of research. There's been some work done in the last couple of years by Richards and Chalup looking at the densities of oysters needed to clean Moreton Bay. They've come up with a modelled amount of 0.09 oysters per square metre to clear the water, and I think it was 0.15 oysters per square metre to actually get some real nitrogen removal happening to water quality objective standards. That certainly shows that it has to be a very dense aggregation to make any effect. The sorts of species that we'd be looking at in northern Queensland are leaf oyster, or the milky oyster that would be appropriate for the tropical waters. And in southern Queensland here, southeast Queensland, we're looking at the leaf oyster, the hairy mussel, or the Sydney rock oyster. They might be ones we could look at. So the leaf oyster is quite a large oyster. It's common to both those areas, and it really has a huge potential for filtration. So that's one that we're particularly interested in. There is a native leaf oyster reef in the Noosa River, which is good to know. And then potential risks, caveats, considerations, whatever you want to call it, things we need to look at. There's a high suspended silt and sediment loads can really affect the filtering capacity of the oysters. Lots of environmental factors that we need to be considering: the temperature, the oxygen, the water flow rates, the particle concentrations. They can all markedly affect the filtration capacity. The population density, as I said, it really needs to be quite a dense aggregate to have a marked effect, as it would have in the past. The partial shift towards anaerobiosis in the long term. There has been some work done to show a higher ammonium concentration underneath the oyster beds. And disease. Well, there is a likelihood in the muddy waters during the warmer months that there is more disease, and so we need to really look at diversity of species so that they can filter out different viruses and disease particles. That would be one way of dealing with that. And translocation of species is a biosecurity issue that we need to be really considering, so we need to use local species as much as possible. Well, America is really streets ahead. They're mapping ocean wealth. They've got this online tool that you might like to check out, the oyster calculator, and they can work out in any particular given estuary, the volume of the estuary, the conditions, the species, as to the estimated percentage of the estuary that could be filtered by oysters, and that really supports the funding applications and the investment. So it's worthwhile checking out. But I really want to, I guess, make the point, like the wetlands, that the oyster reefs do have multiple benefits. Certainly promotes really good marine life around the oyster reefs, really good for fish stocks. 1 acre of oyster reef can provide habitat for 1.5 tonnes of fish and seafood. This is the hook that we're aiming for with our local projects. We're not looking at a water quality outcome so much as promoting fish stocks in the Pumicestone. And also, this is really becoming quite important, particularly in Sydney, for example. They're looking at this outcome for their reefs down there to protect the ocean shoreline from erosion. So multiple benefits there. If we have any time, I'd really love to mention one shellfish pathologist, Ben Diggles, who's many of you I'm sure would know. He's been working in the Pumicestone for many years. He's developed this Oyster Gardens project, which is funded by the National Land Care Program, and that's looking at putting in bags of oysters on private pontoons in Pacific Harbour at Bribie Island. It's a way of really raising awareness and doing some research, but hopefully, you know, that sort of idea of decentralised oyster gardens might have some impact, particularly in canals and harbours. This is happening a lot in America, and using shell that's recycled from local restaurants and seafood outlets. So again, that's happening in America a lot, just starting to happen here. So it's an idea to throw in.
Thanks very much, Susie.